Hey, this is 8-8, large intestine. So after the food goes through the small intestine, next thing it's going to hit is the large intestine. There are three things that make the large intestine unique and different from the small intestine or the stomach. One is something called tinea coli. These are bands of smooth muscles that run down the length of the large intestine and help in mobility. We have the haustra, which are pocket-like little structures that just kind of help increase the surface area for water absorption, and something called epiploic appendages, which are small fat-filled pouches of visceral peritoneum that hang from its surface. Other than just fat storage, they really don't know what other purposes they serve. So let's take a look at those. So here is your large intestine chopped open for you, and the first one are the tinea coli, and so it's a band that runs on two sides, on both sides. So on the anterior and the posterior surfaces of the large intestine, we find these are muscles, but they're kind of small and stringy, so they're kind of unusual muscles for the intestine. Second one are the haustra, which are these little pockets or pooches that run down the whole entire length. And if you kind of imagine it, you've probably seen poo look like that before. So I'm sure they have something to do with the formation of the poo. And the last one says omental appendices. That's the epiploic appendages. And so it's almost like it's melting. It's kind of gross looking. But it's like there's a little fat melting off of these things. And obviously in more obese people, theirs are much bigger and heavier than in someone a little bit thinner. Alright, the subdivisions of the large intestine include, and in order that we would find them, the cecum, the appendix, the colon, the rectum, and the anal canal. The cecum is the very first portion of the large intestine. It's a little pouch that lies right below the ileocecal valve. So when the food dumps into the large intestine, there's a little dip or a pouch that everything goes into first. So that's the first part, and dangling on the outside of that we have something called the vermiform appendix. Vermiform, it means worm-shaped. So it says a worm-shaped appendix, and what it is just lymph tissue that helps play a role in immunity. It's thought to have something to do with high vegetative diets, so like herbivorous animals have very big appendices, and in people they think after we've had a big bout of diarrhea that the appendix will release the good bacteria back into our gut to try to reestablish it back to normal. So here's a little picture kind of showing. So here's the small intestine, the ileum. Here's the ileocecal valve, and then it dumps in here. And so here's like a blind sac. And I believe cecum actually means either sac or blind. I can't remember. So this is the little pouch. Now here's a hole that leads to the appendix. So every once in a while some poo material gets inside the appendix and can infect it, and then that's when you get appendicitis. But usually things are going out, not in. And then we go into the next part of the large intestine, which is the ascending colon. To ascend means to climb up. So the ascending colon means it climbs up, and it starts on your right hand side. It always goes up on your right hand side. Then it does a little sharp turn. So it's going, up, and then it goes and does a little turn. That turn is called the right colic flexure or hepatic flexure. Colic refers to your colon, the hepatic refers to your liver, and your liver kind of dangles around over there. So, I'm sorry, I drew it the wrong way. Should be doing that way because the person's looking at you. So the liver is kind of like right there. So that's why it's called the hepatic flexure, to flex, bend. Then it goes across for a little bit. Oh, I'm sucking on drawing, sorry. I don't have my little pad with me. I'm trying to do it with the mouse. So we have the transverse colon, which goes across the abdomen, and then you get the next turn, down like that. That turn, that corner, is near the spleen, so it's called the splenic flexure or the left colic flexure. So it's another right angle, turn down. And now we have the descending colon, goes down, until it hits this little twisty S portion like that, called the sigmoid colon. Sigmoid means S shape, so that kind of makes sense. So here we go, here's the cecum, here's a little pouch, here's your appendix. So we go up, ascending, and then we have the hepatic flexure right here. And then it goes across to the splenic flexure, it goes down, descending, does a little twisty thingy here, and now you're at the end of the sigmoid colon. Up next is the rectum. So the rectum is kind of like this last little area right in there, kind of like that, and contains rectal valves to help keep things moving or prevent them from moving in some cases. The rectal valve is very important because it makes sure that when you toot, nothing else comes out with it. So you got to have a good working rectal valve, or else every time you toot, oopsie, something comes out. The anal canal is like this region right in here. So the very tip, the anal canal leads to the anus, which is the actual outer hole. The anus itself has two sphincters. It's got an inner one right here, and that one is made of completely smooth muscle, so you don't control that. But what you do control, thank goodness, is this outer one right here. That's the external one, and that's the one that you purposely open or close when you're doing your business. Alright, microscopic anatomy. If we were to take a look at your large intestine underneath the microscope, we see there's no folds, there's no villi, there's no secretory cells, there's an E supposed to be in the middle of there. It's really plain and boring, but it does have a lot of goblet cells because, we want to make it easier to get the stuff out. So a little bit of mucus helps that happen to slide out a little bit easier. The anatomy of your large intestine is made for its main job, which is just absorption of water. That's pretty much all your large intestine does, is to remove extra water so to compact the waste that's coming out. The anal canal itself is made out of stratified squamous because of the wear and tear. So that anywhere where we see high friction areas, we always see stratified squamous epithelium. In the anal canal, we find something called anal columns, which are little ridges like this, or folds inside of the anal canal, and they think that it kind of squeegees out extra mucus and fluids on the way out. This is so nice. And then we have something called anal sinuses, which are little depressions that secrete mucus to, again, help it on the way out. So here's a picture if we were to take your large intestine and cut it in half to let you see. You can see the anal columns, which are these big, thick areas right here. Anal valves, which are kind of at the tip. Anal sinuses are the depressions right in there. And this, they took the surface layer or the mucosa off, so you can see that it's highly vascularized. And it's these little guys, these veins right here, which sometimes decide to grow out here and give you hemorrhoids. Oh, that's not nice. Yeah. All right. Anyway, the last thing about the large intestine is that it's full of bacteria, and good and bad bacteria, but usually good. The good bacteria we need there because their job is to make vitamin K and vitamin B, which your liver needs to do certain processes. And as we are all familiar with, these bacteria do produce various gases and irritating acids that, I said acids, acids that, I forgot what I was saying now because that made me laugh. They produce various gases and irritating acids, which sometimes make your insides not feel so well. I like this picture because it looked like the duck was tooting. Okay. Yeah, I'm done. All right, bye guys.